Hey guys, I got this touch probe from DRO Pros and I thought I'd shoot a little video and show you what it's all about. I'll show you the probe first and how it comes out of the box. You've got a probe here that plugs into the spindle. That jack plugs into the back of your DRO, and then it also comes with this. He calls this a breakaway needle. It's got a ruby tip. The needle is very flexy. And he said if you want accurate measurements, you need to go with a rigid needle carbide tip. But if you crash it, you're going to junk the probe. Now, I talked to them a little bit up there, and I'll draw you some of the scenarios where it does and doesn't matter which needle you use. If we have a part here and we come in and we touch here with the probe, and we come in here and touch with the probe, and then we want to find center, if we're just going to cut, measure, cut it in half, center line, this little flexi probe is just fine. But if this was 1 inch, just as an example, if this was 1 inch and we came in and we touched to measure, and we came over this way and touched and measured, we'd end up short because of the flex. Because when you come in and touch, it's gonna flex this way. When you come in and touch over here, it's gonna flex this way. So this matters for getting actual measurements, but doing centers on an OD like I'm demonstrating here, or on an ID, doesn't matter. You can go with the breakaway. So let's get into the instructions and see what they talk about for setting it up. It's a 2-page sheet, not too complicated. First thing they warn you about when inserting the stylus, do not over tighten. And they talk about the hub in the center. This is your hub here in the middle, and you can see it's on a 3-axis gimbal. And this is made out of Delrin, non-conductive. So it's plastic, even though it looks like, this aluminum housing or this anodized housing here, it's not. So be very careful with it. And when you tighten your tip on there, you want to thread it in, and then they give you a little tool right here to tighten it. It just slips in this hole. You are tempted to just hang on to it by the outside and go for it. Don't do it. Grab it by this inner and just give it just the slightest tightening. That's all it needs. It doesn't need a lot. So that's that part of the probe. Oh, this also works in the Z-axis straight down, so you can touch off this way. So it's not a Renshaw probe. It's not going to be as hyper accurate as a Renshaw probe, but they assure me that if you set it up the way they tell you to, it's going to treat you really good, and it's going to be pretty darn accurate. Good enough for the girls I go out with. So we're going to see what it's all about. We're going to go through the instructions and see what all they talk about we need to do to get this thing set up. So let's get into this a little more. Well, when you take it apart the way they instruct you to, the first thing you notice is they're not kidding. Whoever was responsible for greasing these things just went crazy. And this is what I've got here, just like the picture. And all I did was get in here with a swab and swab out all the grease and get all that out of there. So these are all pretty cleaned up now. And it's ready to go back together. Next up is aligning the tip, and we actually have to do that on the machine. The probe itself sits in a 10 millimeter, or the stub is a 10 millimeter. I'm going to unscrew that and cut it down. 10 millimeter and 3/8 are very close. So I just need to cut a little bit off of it. I'm going to take that down to 3/8, and then we'll go from there. But I'll show you how this all goes back together. These sit in here like so, and then there's a spring that goes down in the center, and then you see there's the contacts. those gold-plated contacts, and they were smeared with grease pretty good too. Okay, well, we got it all put back together, and I want you guys to notice these are just the cap screws here, here, and here to assemble it. But then if you look down inside in between, you'll see the 3 axes line up with these 3 screws here, and these are kind of like a jacking bolt. You go in here and you actually tip the unit 3 ways, and what that's going to do is that's when we've got it in the collet, we're going to use that to true up our stylus to make sure our stylus is running on center line. I've already taken this shaft out. You can see it's trimmed down. It's trimmed down to 3/8 here, so it'll fit in an imperial collet. And we're going to go for this this stylus here, which is the rigid one. And we're just going to give that a little snug there. So my cord's already pinned back. The next thing we need to do is align the tip, and that's going to be those 3 jacking bolts we did there, there, and there. So you're actually jacking around on like a tripod. So it's should be fairly simple to get this ball trued up on the center line. Here goes my compressor. And they show you doing it here. I'm going to show you another way that's going to make it a little easier. I've got an indicator, and as long as we're doing this, let's talk a little bit about indicator tips. Okay, so we're indicating on that ball right there. Now if we had a probe and a ball, and let's say we've got our indicator here and our indicator body, and we're coming in and we're trying to do it with a another ball here. So we're working one ball against another ball, and that's not very good averaging. What we're going to do is I'm going to get an indicator set up. I've got a flat face indicator where the tip of it is actually a lapped square surface. So we get better averaging with this type of indicator with the square end than we do like a ball tip. Doing a ball against a ball is never very accurate. So let me go get the gauge I'm going to use here, and we'll get it set up on the mill and actually give it a quick measure. All right, I'll bring you back for that. Okay, so here's what I was talking about. This is a little Federal tense gauge, and if you look at the bottom here, this is a kind of a domed tip, but that just comes right off of there. And this is a polished and lapped square tip, which just threads right on here. So this is what we're going to use on that ball to to measure the run out on that ball. There's another attachment here, which is like a blade, which is very nice for getting down into O-ring grooves too. So having an indicator that has different tips, has its uses. You just need to know when to use them. General purpose, the little rounded one's pretty good. That blade one's handy for O-ring grooves and snap ring grooves. And if you're indicating to a round surface or a tiny round surface, man, that little flat one is really the ticket. So that's what we're going to use on that. So that we're going to have an indicator kind of set sideways here, and then we're going to be indicating right to that ball like that. Okay, so let's go get set up for that. Okay, well, we're set up on the mill now, and we've got our wrench ready, and we've got quite a bit of run out, almost full scale. That's almost 10 thousandths. Let's go to our lowest low here. It's right there. Let's get zeroed up on that. I'm using a fine adjust bottom arm to get that done. So yeah, it's 9 thousandths of run out. But let's not be alarmed. Let's find our highest high. And over on our highest high, we're going to go in between the cap screws to those jacking bolts, and we're going to tighten those. As we tighten those, it's going to take that needle and push it away. So we're actually going to tighten our highs and loosen our lows. So let's get in here on this one. Let's see what kind of cause and effect we get here. Oh yeah, we're getting plenty of adjustment. I'm just barely moving that thing. All right, let's go about that much. Give it a little spin again. Back to that one again. Give it another thou. Okay. I'm going to get some of this preload off of this gauge. I'm trying to keep tension off of that thing. Just trying to find our low again. Our lowest low. I've just got my cord kind of tied up out of my way so I can spin my spindle. Alright, I think that's our lowest low. 0. Alright, let's find that high again. So what a dramatic improvement already. So that's 2 thousandths high. We're going to tighten this high slightly. And take away half the error. Two thousandths there. Let's take away half that error. That one's still a little bit low. Take a little more out of that one. That one we're pretty happy with. That one's a little high. This is just a one-time thing. After you've got this thing set, you're done with it. Okay. We got it running pretty straight now. Let's get it zeroed up again. See how close we can really get it. So there's that one, 0. That one there. That one's below 0. That one there is 0. So we need to tighten those 2 zeros and leave the one that's below 0 alone. Still tightening our highs. Just do that one a little snug. Go over here to this one. Alright, that's running pretty darn good there. So I don't think that's going to give us any trouble. Next up, we plug it into the DRO, and then we get to play with it. So I'll get a camera parked on the DRO and start playing with it a little here. Okay, next up we need to measure the ball on this thing. And I need to get a fairly accurate dimension so I can plug it into the DRO. And I think this is the last last step of the calibration. Coming up with 118.2. We'll go ahead and turn it 90 degrees and check it that way too. Same thing. 118.2. So 118 thousandths. So we're going to go, let's see, 0.1182. Enter. So that's my ball size. It's already plugged in, and we're ready to start measuring. And we can use all these for different coordinates and things like that. We'll get a gauge block and throw it in there, and let's see what happens. Okay, well, I thought I'd try this thing out. We've got it all calibrated. I got a gauge ring in here, just held in just kind of lightly with a V-block. Nothing, I'm not really gronking down on it too hard. I don't want to deflect the gauge ring. But let's find center of it. I've got it just kind of eyeballed right now. So let's give it a try and see how we do. What we're going to do here is we're going to select ID. You've got OD, ID, steps, and other different features that you can measure. So we're going to go to the ID, and now we're going to select which axis we're going to use first. I'm going to use the x-axis first. Now it's telling me to move to the start position, so I'm going to come down and get it where I'll make contact with the gauge ring. I'm going to come up to my first one and just move till I hear a beep. Okay, see, it's flipped me over and says now move to the end position. And I'm going to go to the other side until I get another beep. And now all I'm going to do right here is I'm going to hit the half button. I'm going to cut that figure in half. That's going to tell me where to go. When I hit 0, I should be in the middle of my X. Alright, so we're good on X. Now we're going to go to Y. We're going to hit the little recycle button. Basically it starts the whole operation over. And we're going to select the Y axis this time. Okay, so I'm ready to do my Y. I'm going to unlock my Y and come to my first position, listen for the beep. And then I'm going to go to my second position, listen for the beep. And now I'm going to cut that in half again, and now I'm going to move back to my 0. Or thereabouts. This thing reads out in 2/10 increments. There we go. Let me lock that axis, see if it locks without moving. I move 4/10. What'd that do to us? No. You guys are advantaged. You can see it better than I can. Well, 2/10. What's 2/10 between friends? Okay. So we're 0, 0 on X and Y. Let's throw a good old throw an intercall on there and see how we really did. Okay, I think I can swing that around and keep this cord out of the way. Okay, we're zeroed up in the back. And some of these you may have to take my word for it. I'm going to swing it around this way. And we are zeroed up in that axis. Literally zero, so I'm not seeing any movement. Half a thou. Half a thou. So we're half a thou off on the X, and we're dead nuts on the Y. So pretty good. So that was a pretty easy center find there. Okay. That's pretty cool.